upload lah. I just record lah, but no need upload lah. I think no one will see lah. Okay, I on this class because I feel you might need support lah. Just give you 精神上的 support. Some just support lah. Or if you have any question to ask, can ask any concept. I try to make it simple. Okay, light and optics. This C and V. C is speed of light. This is speed of wave. If they ask for refractive index. Refractive index. Okay, refractive index got 4 ways to find. And then this C is different. This C is critical angle. It's incident angle that make the light refract in 90 degrees. So this is I when I equals to C, 90 degrees refraction. Okay. Then sine I over sine R. Sine is incident angle, but always remember it's the less dense part. Okay, less dense part means low refractive index. Like if air and water. So the less dense part would be air. Okay, then this one, real depth over apparent depth. Be careful, this is not height. Even they write height, but actually it's depth. So remember that depth we count from the top to the bottom. And then height we count from the bottom to top. Okay, so actually it's depth. So this depth can be related to Form 5 Chapter 2. This H rho G actually is depth rho G. Okay, it's depth rho G, not height rho G. Okay, so now this one, 1 over F equals to 1 over U plus 1 over V. Normally focus positive if convex lens, but concave lens is negative. Okay, this one just ignore. Alright, so now linear magnification means how much the image enlarge. So we use the image distance divided by object distance. And sometimes if they give height of object and height of image, we also can make an equation in this way. You just make V equals to height of image, U equals to height of object. That's it. Okay, then force of motion. This one, F equals to Kx, Hooke's law. Okay, this K, let's say K equals to 10 Newton over 2 cm. Okay, your K can leave it as 10 Newton per, 5 Newton per cm. For K can. But if they ask you to find this, what is this? This is elastic potential energy. Your X must be in meter. So your K must be in meter too. So let's say if you want to make K as SI unit, so you must change to 10 Newton divided by 0.02 meter. Then you will get how much? 500 Newton per meter. What does it mean? Means 5 Newton you can tarik 1 cm away. So if you want to make 1 meter away, we use 500 Newton. Just the concept lah. Most of the spring cannot have 1 meter long. Normally cm lah. But remember, elastic potential energy in Joule. Joule SI unit, then everything must be in SI unit. Meter cannot be cm. So remember, write your info and check it is cm or m. Okay, pressure. Pascal principle is saying that pressure is transmitted equally. Means in P1 equals to P2 hydraulic principle, hydraulic jet. Okay, so this formula lah, not given, modified from this formula. Okay, P equals to H rho G. Actually, this H is that, yeah, is that count from top to the bottom. From the surface of water to the object. Okay, and this is liquid pressure. Okay, then atmospheric pressure, they might tell 76 cmHg. So how to change to Pascal? We use H rho G. And same thing, H is the depth. So, and then it is in Pascal. So you must change 76 in cm into 0.76 meter times rho times G. Okay, and this is density. Density equals to mass over volume. Okay, and one more formula not given. Buoyant force equals to rho Vg. Okay, rho Vg. And this is Archimedes' principle. Actual weight equals to apparent weight plus buoyant force. So actual weight is mg. Apparent weight, no formula, but buoyant force is rho Vg. Okay, Archimedes' principle, Pascal principle. Actually, principle on most of the principle were three only. Pascal, Archimedes, and Bernoulli. Bernoulli means velocity fast, velocity of air fast, pressure of air lower. So and the ballet lah, the aerofoil, something lah. Okay, so electricity, this one can be the definition for current, definition for voltage, definition for resistance. Okay. Then this one is when they ask for internal resistance. When they mention that, use this. And then P equals to E over T. Just now remember the heat, the PT. Where is the PT come from? Actually, PT means you cross multiply up P. So PT equals to energy. So most of the time, electrical energy, we use PT to count it, okay? Or if we translate, we also can say, if they ask for P power only, power equals to 1500 watt, what does it mean? 1500 joules of electrical energy is used in 1 second, okay? Then if they ask for these two are electric field strength, means this is force divided by the charge. So how much force is owned by one column of charge? So how strong is the electric field? And then if they ask to find cost of energy, so how to find 1 unit of electrical energy? We use 1 kilowatt hour times, let's say they say 1 unit 0.28 cent, just times only. Okay, so electromagnetism, this is a transformer. So you can see that voltage secondary is directly proportional to the number of secondary coil. This is voltage for primary coil, directly proportional. Then this one output, input, this is efficiency. So if they say efficiency 85%, means you substitute here 85% equals to output power divided by input power times 100%. Okay, so Faraday's law and Lenz's law. Faraday's law say what? The current, induced current, is directly proportional to the rate of change of magnetic flux. So Lenz's law, you just say direction of current opposite. Just remember this to the rate of change of magnetic flux. I just say that on. Then if where and how will it swing or deflect or what? Don't worry, it's from 6-1. Okay, just Faraday and Lenz. Okay, then electronic. This is the thermionic emission. Thermionic emission means when the metal is heated up, electron will be emitted out. Okay, so the electric potential energy is E equals to EV, and then means what means this is metal. Okay, how can the electron go up? You must have high enough electric potential energy. Then when this one go up, it will change from electrical potential energy, it will change to kinetic energy. So we can use EV equals to half mv squared. This V is voltage, this V is speed. Capital V, voltage, small v, speed. Okay? Can I see the definition of Lenz's law again later? Let me see. B6 form 5. I should type. Form 5, B6 textbook. Any flip. I think it's around 180. Lens, look. Lens. This is Faraday. Lens. Lens, 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 lens. Lens lock here. Let's now state that the induced current always flows in direction. They mention direction that oppose the change of magnetic flux that crosses it. Actually, what does it say is uh, when we put the magnet towards, okay, so this side, this side, this side. Okay, it will produce current. Either current flows, this is, let's say this is a clock. The current will either flows clockwise or anti-clockwise. So clockwise, if the current flows clockwise, so electromagnet is like that, very funny. If you got current, then you will cause magnetic flux. You will you will create magnetic field. Then if you got magnetic field, you can induce current. So like that, they're related to each other. So now let's say here, this is CCC, means current carrying conductor, means current starts to flow, then here got magnetic field. How do you know this magnetic field is north or south? Depends on direction of flowing, clockwise or anti-clockwise. Okay, then how to say that? Let's see, N and S. If we put okay, like N and S. If we put an arrow at the edge, you will find out north goes anti-clockwise. Then if you put your S like this, then you will find out south clockwise, north anti-clockwise. So look at this. This is clockwise S, this is anti-clockwise north. Okay, so when you move the when you move the magnet inside, okay, so if this is north, you'll find out the current flows in north direction means anti-clockwise. Okay. But if you pull the north away, you'll find out the current flows in clockwise, south. Then it becomes south. Okay, then it becomes south. So this is what Lenz's laws say. Induced current always flows in a direction opposed to the change of magnetic flux. So if you move north in, it will move clockwise, means these things now, this side, the whole thing now become north. Okay, then when you pull out the north, then this thing will flow the current into clockwise direction, become south. Okay, so, or you can remember in another way, say that if north goes in, it will become north because repel. Then when north goes out, it will become south, want to direct the north back 这个算是很冷门的题，超级冷门的题。可是这几天都有人一直在问我，不知道为什么。These few days, many people ask me about this. And then, I think it won't come out for very detailed. It won't ask you too detailed. But SPM never asked before. Never. STP, yes. STP, you must know where will it go and then how is the deflection of ammeter, voltmeter, galvanometer. But I tell you what, even though you have galvanometer also got positive and negative, some, or voltmeter, some. So if you pasang terbalik, the direction different again. 哦，是哦，你们史加拉出爆冷题哦，是哦，史加拉哦。I don't think. Okay, I tell you what, I observe the sastra and the art like language or what, yeah, they might come up the very 冷门题 means what? Means seldom come up question or never come up question. But physics is hard. It's hard to come out the very unusual question. Okay, because physics, everything is hot already. So from my time to now, actually not so much change. The topic seldom change. Now what is change? The way they ask questions change. Okay, so I don't think. See, they also never guide properly, you know. They just say, this one deflect to left, this one deflect to right. They never show properly how is the connection. See. See, galvanometer got positive, negative, got positive, negative, Then if you put this side and if you put this side will be different. If they really want to come out this kind of question, they should show you the circle, but they never show. They should show you the circle like S is clockwise, like north is anti-clockwise. See, they never show. Somehow they never ask you to test for the galvanometer. They didn't show it's positive or it's negative. So I don't think they will ask. Last time I was in matrix, yes, wow, they asked a lot. And they really teach how to see the direction, how to see the deflection. Okay, now direct current, see, they never show properly. Never show, just one page only. Direction to the left, to the right, doesn't matter, don't worry one. So you just need to remember Lenz's law opposite to the change of magnetic flux. Direction. Lenz's law about direction. Faraday's law about how much current is induced depends on the rate of cutting of magnetic flux. Okay, so do not worry too much. Okay, so now this is about transistor. Transistor got NPN and PNP. Okay, so far. Textbook got show, but so far SPM only asked for NPN. PNP is almost the same thing. Okay, so this is we now only got IB, then only got IC. So this is how much the factor of magnification of the current. This one be careful because sometimes they will say the base current is 10 micrometer. Then the collector current is 1 microampere. Actually, which one is bigger, B or C? IB or IC, bigger current? Which one has bigger current? C got bigger current. Yeah, correct. C for bigger current because M means what? M means 1 times 10 powers of negative 3. Means 0.001. Micro is what? Micro is 10 times 10 powers of negative 6. Means 1, 2, 3, 4, 5, 6. So 0.0001. Okay? So be careful about prefix. I'm worried about your prefix. Forgot to change. Like for example, P equals to 100k Pascal. Can you please interpret this for me? So actually this is equals to how much? Kilo means what? Means 1000. Okay, so this one actually is 100,000 Pascal. Or since you're used to the standard form already, you can say times 10 powers of 3 Pascal. Okay. Then nuclear energy, nuclear physics, half-life, how many half-life you draw, how many arrow. This one you don't know also doesn't matter. As long as you can draw the series, you can count, don't worry. This is not so important. As long as you can draw the series. So E equals to mc squared. This m must be in kg. But normally they will give you the unit AMU first for U. Say for example, 4.03 U. You remember times this one as in kg, then only you substitute C. C is around here, speed of light. So Now, here we use speed of light and also just now. N equals to C over V. So yes, this is also speed of light. You don't know? You can find here. Okay, now last, the quantum physics. Quantum physics is a must. Must recall back the spectrum of EM wave. RMI love means V, Q, X, gamma. Radio wave, microwave, infrared, visible light, ultraviolet, X, gamma. So the visible light, Roy give birth. Okay, then the R1 is long lambda, so low frequency. So another side will be short lambda, high frequency. So long lambda got what benefit? Long lambda actually can propagate further, can go further. But for quantum physics, our E equals to HF means what is it? This is light energy. This is light energy. Then this energy depends on your F, means higher F, higher energy. So violet light has higher energy than green light, okay? Or blue has higher light energy than green light. So E equals to HF. That's why. That's it. Then because this is wave and all of them has wave speed, so actually this formula comes from the wave. The wave say V equals to F lambda. So now C equals to F lambda. Then you rearrange it, you'll find out F equals to C over lambda. Okay. Then this is photoelectric effect. Photoelectric means what? Photoelectric means when the light shines on the metal, let's say, okay blue lah. When the light energy shines on the metal, electron inside here wants to go out. But they need energy to break the bond too. So let's say there are 10 joules of light energy. Then this one will absorb 4 joule. So what is this 4 joule? This 4 joule, wrong. This is HF. This 4 joule would be your work function. Work function means minimum energy absorbed. Then this electron will go out with kinetic energy, 6 joule. Get it? Light energy total. Absorb minimum energy, so they go out for work function. Then energy go out. Kinetic energy that go out is 6 joules. Okay. So E is HF. E is HF here. E is HF. W naught is HF naught. Threshold frequency. And half MB squared. Most of the time they won't ask you this, but they will say, if you have light energy and work function, can you find kinetic energy? Yes. Kinetic energy equals to light energy minus work function. Okay, so most of the time this is what they do Then do you know energy for light energy? Do you know formula for light energy? Yes, HF. Do you know formula for work function? Yes, HF naught. Threshold frequency minus that. Okay, so G equals to 9.81, not 10 9.81. Then G, this is Form 4 chapter 3 just now and this is the H, Planck constant H. Okay, all given. So that's it for formula. Okay, let's see this one. Actually not hard Okay, so like this one Diagram 9.1 shows a bar magnet is moved closer to the solenoid. The deflection of galvanometer can be explained, Okay, so now what is meant by electromagnetic induction? If you don't know, never mind. So state the polarity at X and Y. Okay, so now if we use the Lenz's law just now, you N inside, N go inside means this one will become N, no? Okay, this one will become N, no? So now this one will become anti-clockwise direction. So it's north. So if here is north, y, x is north, y will be south. Okay. Determine the direction of current flows through the galvanometer and state the deflection. Okay, this one we accept. Actually, yeah, we accept both sides. Anyway, as long as deflect can. Because as I said, positive and negative, if they see they didn't show. Since they didn't show, as long as you say deflect left, right, okay, also can accept. Okay, deflect left, right also can. So the direction of current flows, you can say x to y can, you can say y to x can. You want to say left, you can want to say right also can go. Because they doesn't show positive or negative connection here. Okay, so explain your answer because there's induced current flows into the circuit. Okay, based on EM induction, how induced current can be produced in the solenoid. Okay, now that. Okay, now this is okay, this one the common mistake students do is this is a pot and induction cooker. Here got two things. Up here is pot. Down here is cooker, is the stove. So now read properly. You're required to investigate the characteristic of an induction cooker. So it's induction cooker. But when I mark the paper, many students do what? Many students misunderstand. They are going to modify pot. No. We are going to modify induction cooker. So tomorrow, when they show diagram, if there are two objects, make sure you look at the proper one. Okay, you look at the proper one. Okay, so now induction cooker is the stove, not the pot. Okay, what type of power supply? What do you think? AC or DC? By the way, do you know how to make induction? What's the concept of induction cooker? Okay, induction cooker actually is like our induction cooker actually is like our transformer. Actually, how transformer work? Here got AC, then AC will make the magnetic flux. Okay, will make the magnetic flux move to the soft iron core, and then this soft iron core will make the magnetic flux cut on secondary port. So here we'll have induced EMF. Okay. Then if you want to make it hot, actually it's inside the pot. Inside the pot. Inside the pot. Okay, Inside the pot, we put something can something has high resistance. So when magnetic flux come from the cooker. Magnetic flux cut on the metal inside the pot. So it will have the eddy current. Eddy current means it will make your pot very hot. Okay, so actually it's not induction cooker heat up the pot. We are using the pot itself to heat up itself. We are using the electromagnetic flux cut on the pot and make the pot heat up itself. Okay, so now the type of power supply, same as transformer, must be AC. Material for the surface of cooker, okay, cooker means here, not pot, huh? What do you think? Steel or ceramic better? Or you can just go to your kitchen, steel or ceramic better. Okay, actually it's ceramic better. Yeah, because this one no need heat up. This one no need hot one, no need. This one just used to, and you can see most of the induction cooker using glass. Okay, right? Let's see. Induction cooker stove. Actually, it's stove. Now you can see most are glass. The surface are glass. Surface are glass. So actually glass have same function as ceramic. Actually, we don't want them to be heated up. We don't want them to be heated up. Glass is like ceramic. Okay, let's see, got ceramic one. Cover with ceramic. Most are glass. Hey, since you learned chemistry, I believe you have learned ceramic and glass made up by silicon, right? Yeah, 陶瓷. Yeah, both of them made up by silicon. Okay, 陶瓷跟 glass 都是一样 same element 啊。So why we use ceramic? Because we want to hot slower. Then why using this induction cooker, induction stove, after that it's still hot? It's because the hot from the pot, because the pot too hot. The pot too hot, then the heat transfer to the surface. That's why we put glass or ceramic to prevent the heat, to make it hot slower. So you can say hot slower, you can say high specific heat capacity, you can say prevent from burning or something. Okay, then material of the base of the pot. Material of the base of the pot. Okay, material of the base of the pot would be iron, because if not iron, it cannot cut magnetic flux, cannot produce induced current. Okay, so that it can produce induced current, or it can produce eddy current. Okay, eddy current inside the pot. inside the pot so that it will become hot. Good heat conductor also can. You write a few lah. Good heat conductor also can. Write more than one. If you cannot remember this, never mind. Heat also can. Always remember write 2 to 3 reason. Don't write one reason only. Okay, then the last electromagnetic coil. Copper lah. Like our transformer. Electromagnetic coil means our transformer coil lah, copper lah. Why? Low resistance, so high current can pass through. So current will induce what? Induce sorry. So current carrying conductor means this one will produce magnetic flux. So this one you can say increase more magnetic flux. More magnetic flux. Okay. So explain the suitability of each characteristic of induction cooker. Determine the most effective conduction cooker to be used to cook food more efficiently and economical. Since they say more efficient, effective, economical. So you cannot repeat this as your reason. So always highlight it. Okay, so answer is L. Okay, then this one. Okay, so this one quite hard. Okay, because you can see here, this is series circuit. This is series. And this one is series and parallel. Okay. Normally we draw, normally the battery draw like that. The battery draw like that. Series. But now they draw like this. Still series. They try to cheat you. Okay, so which one is the best one? So that what? See their criteria. Their EMF is the same. Okay, so what do they want? So I suggest you all skip this one first. You look at the question first. Study and determine the most suitable electric circuit that produces brighter light and is not easily flammable light source. Means it won't burn. Okay, explain the suitability. So brighter light. So if you say brighter light cannot, but you can say what? You can say high intensity of light. Intensity. Yeah, as long as you change, okay? As long as you change intensity. Wait a minute. Okay, so if series, but in series, sure cannot be bright one. So cannot. So then we see these two only lah, either, but always in parallel. Why parallel? When they are in parallel, we will get 1 over r equals to 1 over r over 1 over r2. So when, let's say each is 2, so we will get what? All of them will become 1 over 2 value. Yeah, let's say that 1 over 3. And finally, if series 3 plus 3 plus 3, 9. But this one, 3, 3, 3, then they will become 1 over 3, 0.33. So this is called effective resistance, will be smaller. Okay, effective resistance will be smaller. So, but if this one series, then the voltage will be too high. Voltage will be too high means, and some more you can see high resistivity wire. We don't want that, we want low resistivity. So answer is this only lah. Okay, answer is this only. So the connection of dry cell type 2, why type 2? Because same thing, when this one have external resistance, all of them also got internal resistance. Let's say internal resistance is 0.1 or 0.1, so this one will become 0.2 internal resistance. This one becomes 0.2. So you will get 1 over. So effective internal resistance will become 1 over 0.2 minus 1 plus 1 over 0.2. So it will be lower than 0.2. So here we can say the effective resistance for light bulb become lower, and the effective resistance for battery also lower. So higher current. Okay, so connection type 2 because effective internal resistance lower, so higher current is produced. Then LED arranged in parallel, same thing, effective resistance lower, so it will be brighter. Can I say brighter? Cannot, but higher intensity. Why cannot brighter? Already written here, cannot. And also, low resistivity wire means the current is bigger. Okay, low resistivity wire, you can say because it has low resistance. Resistivity. Now this is R equals to rho L over A. Rho is resistivity. R is resistance. They are a little bit similar, but they are different physical quantity. So you can say low resistivity, you can say low resistance, something. Okay. Then choose the most suitable circuit, give the reason. So you just repeat that. Actually, you can just draw the table, right? Draw the table and make your choice. So they purposely make 10 become 8 plus 2. Okay, so then you can see here, these two, they connect in parallel. Means what? Means you can make the effective resistance become smaller. Okay, so 1 over R plus 1 over R, 1 over 1.5 plus 1 over 1.5 equals to 1 over smaller internal resistance. Okay. Then reading of ammeter means what? Means V equals to IR. But they mention internal resistance, so cannot use this. we use this internal resistance. Understand? Okay, so now the last one is the section C. So you can see the power supply 11.1A, 11.1B. Then this one is 11.2A, 11.2B. So when you make comparison, remember must mention A or B, 1 or 2. Okay, so you can, let's see the difference, read properly. 11.1 and blah, 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 blah shows initial temperatures of liquid X before being heated by identical immersion heater. Okay, means these two are before. So you write for yourself. These two before. Then you can see 11.2A and 11.2B shows final temperature of liquid X after being heated for 10 minutes. Then you can see that this temperature is lower, this temperature is higher, so this is after. Okay, and see what based on 11.1A and 11.1B, compare initial temperature and mass of liquid X before heating. So let's see. Temperature before, the same. If you draw a line, you can see temperature before for both are same. Then what they ask? They ask mass. So obviously, this one bigger, more than this. So this one asking 11.1A and 11.1B. So you must answer A and B on 11.1 AB only lah. Okay, so for initial temperature equals, so mass of 11.1A is bigger than 11.1B. Make your sentence. If you just write this directly wrong, make sentence. Make sentence. Then they say 11.2A and 11.2B. Compare the rise in temperature of liquid after heating. The rise of temperature means which one will rise more? Obviously, 11.2, 11.2 AB. Obviously, 11.2 rise up more. 11.2 rise up. Then see what they ask. They say relate the mass and rise in temperature. So we see the mass equal rise in temperature. Temperature. Sorry. Blur case. Rise is the mass. The mass and rise in temperature. So actually we see these two enough. So you can see my A and my A is on the left. So you can see what when the direction of the sign is opposite. When the direction of sign is opposite, inversely proportional means mass increases, rise of temperature decreases. So same thing lah. You cook less water, it heat up faster. You boil more water, it heat up slower. Then state the physical quantity that must be kept constant to deduce the relationship between the mass and the rise in temperature. So what should be kept constant? No, this one. What should be kept constant? Yes. So actually this one cooking things, right? Got temperature, right? So we can use it as Q equals to MC delta theta. So if you want to make sure these two relationship, so you must make heat supply constant and specific heat capacity constant. Yes. You can write either one or you write two also. Okay. So how many marks here? 5 marks. First mark, the initial temperature. Second mark, the mass compare. Third mark, rise in temperature compare. Fourth mark is relate the mass. Then the fifth mark is tell the constant. Sometimes they ask two relationships, sometimes they ask for constant. So you try to find back formula, got heat, got rise temperature. Find out the formula. They are asking these two, so these two constant. The heat from the sun heats up the sand on the beach and the seawater in same period. Okay, so you better draw it up lah. Heats up the sand. So this is sand. This is water. In the same period, so same time lah. Means heat is the same lah. Heat is the same. It's found that the sand heats up faster than the seawater. Explain the above statement. Why the sand heat up faster means what? Means changes of temperature is higher. Changes, so this one changes of temperature is lower. So for example, in the beginning, both of them are 27 degrees Celsius. After you heat up, same heat, same amount of heat. This one may rise up, become 37. But this one just 30, maybe 29. Why? They are not asking you sea breeze or land breeze. They are just asking why the rise of heat up faster means rise of temperature is different. Why? Use back our formula. If mass the same, heat the same, this one rise up fast. Why? Specific capacity different. I just say specific capacity of sand is lower. So heat up faster. Then specific heat capacity of water is higher, so heat up slower. Heat up slower means the rise of them. So you cannot use back heat up faster. You say rise in temperature. You use back this sentence, rise in temperature. And actually, they want you to change sentence, but you got key. Okay? So the last one, I tell you this one, green building concept. They prepare 15 modification for you. So this green building is built by using a positive impact on climate and the natural environment. Okay, using appropriate physics concepts such as the use of appropriate material and appropriate design to increase ventilation and ensure the temperature in the house is not high. Increased ventilation means what? Means you want more the air can be exchanged more. Okay. The proposal must include specific heat capacity of material and the type of material used as the walls and roof of the house, the number of windows and the design of the house. 通风没有错 ventilation 通风。Okay, so 他讲什么？他其实是讲，这里你要很小心啊 ，here very be careful because they are asking walls and roof. So when you draw your table, you better draw in this way. Number one, wall. Then wall got specific capacity of material must be high lah, so that not heat is not hot easily lah, not hot fast. Then type of material used, you have many things to tell lah. For example, heat insulator. You can write a lot, right? You can write a lot, a lot, a lot. For example, you want, as I told you before, you can tell the name concrete. You can tell the name concrete. You can tell heat insulator. You can tell glass. Actually, glass can. Whatever. Then number two. So actually here you got 2 points already. Use cement for walls and ceramic for roof can. But ceramic a little cannot ceramic can. Then you say wall. Wall. One more specific capacity. Sorry, roof. One more, you must tell us specific capacity of the roof must be high. Same reason, no problem. Then roof, if you want to say ceramic, you want to say glass, you want to say ceramic, as long as heat insulator. So here actually you got 4 already. Okay. Then you got what? You got number of windows, more lah. Number of windows, more lah. Why more? If you say increase ventilation, cannot. But if you say exchange of air, increase the rate of exchange of air inside can. Okay. Or you can say let more ventilation actually means what? On top of the roof of the hall, normally we can see the ventilation fan. Another one is also we want to let the heat go out. The hot air. We want to let the hot air inside the house go out. Okay, so we can say more hot air can go out. No? More windows, more hot air can go out, or more cold air can go in. Okay, then design of the house. Design of the house, actually we must make a very high or very high building. High building. High ceiling. Ceiling, they don't accept. They accept the building, the whole building must be high. I don't know, maybe high ceiling, but you one layer also not enough. Maybe like that. When I ask this, they also not sure, but I guess lah, maybe one floor only, your ceiling might not high enough. So actually you cannot reduce heat. But if you have higher building, then maybe the hot air will maintain up here. At least you got one layer to prevent the hot goes down lah. So they only accept high building. Okay, so I think tomorrow just pass the test is enough lah. Okay, I mean just let it go lah. Okay, just let it go. Don't worry. Okay, any other question? No question. Okay lah, just goes. Maybe if you want study just a little bit while then go sleep. Okay. Okay. Good luck everyone tomorrow. Okay. Thank you everyone. Bye bye. Thank you. Bye bye. Bye bye.